Today I will talk about Schwarzschild solution of the field equation in the free space. And I have to emphasize this solution is in the free space. That means in the absence of matter, مفيش matter. In fact, Schwarzschild find the solution for the field equations soon after Einstein introduced the fields equations. يعني في عام تقريبا 1916. وكان هو أحد المجندين يعني في الحرب. تصور واحد جندي يعمل الكلام اللي راح نتكلم عنه اليوم. المحاضره there's a lot of algebra in this solution. So in fact the details will be given to you in the WhatsApp. Okay. I will be obliged to omit certain details because it takes so much time and they are unnecessary. So I will focus on the basic ideas and also on the basic method to construct a solution for the field equations. Now if we go to the field equation in free space, that means the energy momentum tensor is equal to 0. And the solution I am seeking is to find a solution of the Ricci tensor equal to 0. So in fact, this is the equation for which I am trying to find a solution. In general, the line element could be written as ds squared, c squared, dt squared minus etc. But this line element is really very, very simple. And I don't know if this line element corresponds or can really reflect this equation. Now I will seek a line element of this form. So I put here A, B, C, D. Now these quantities A, B, C, D are unknown quantities. All what I know is that these quantities, I will take them as a function of R. So I thought these quantities A, B, C, D, a function of R. Now there's one step I want just to remove from here. I will assume that C and D in the equation, it is not assumption. We can prove it, that C and D in the equation are equal to 1. And I am left with this equation. ds squared, this is the line element, equal to A, C squared, B squared, etc. Now in this equation, I have A, a function of R, and B, a function of R. And the whole solution is to find what is A and what is B. If I find what is A, what is B, I almost solved the problem. But there's a long way to do this. The question is, what kind of function I would suggest for A and B? I said A is a function of R and B is a function of R. Look, what is suggested is that this function A is equal to E to the power nu, and the nu is a function of R. So this is A, and this is B. Of course, one can ask me, why you are choosing this A equal to E to the lambda, a function of R, and B equal to E to the mu, function of R, etc. The answer is, if I do this, I can find an easy solution. One say, what is easy solution? I said a consistent solution. A solution that is consistent with the field equation. So let us try this. Let us try to find what is nu and what is lambda here. If I find what is nu, what is lambda, I can find out s squared. But I will discover that this mu of r and lambda of r, in fact, are related directly to the field equation. So these quantities are related to the field equation through the Christopher symbol, as we are going to see. So my equation that I'm going to solve is this equation. This is A, which is e to the nu of function of r, and this is B, which is e to the lambda of r. Now, look at the Christopher symbols I have. I have 64 Christopher symbols. I have to identify these 64 Christopher symbols. And I can reduce the number of these because I know that Christopher symbols are symmetric. For example, I have 3, 1 and 1, 3 are the same. 2, 1 and 1, 2 are the same, etc. 0, 3 and 3, 0 are the same. So they are symmetric, and using this symmetry, I can reduce these 64 Christopher symbols to just 40. So in fact, I have 40 Christopher symbols I have to find out. Now, how to find the Christopher symbols? I will go to the language equation of the geodesic line. This is the equation I'm going to use to identify the Christopher symbols. This equation contains all the Christopher symbols, or the 40 Christopher symbols we just see.
يعني دكتور ده 40 معادله بس السمبل دلوقتي المعادله دي رقم دي اصبحت 40 معادله صح؟
So let us see how I extract Christopher symbols from these. Okay. So I will go back to an equation that you know. Everybody talking about last lecture. The Euler line equation. This is the Euler line equation. So I have to identify what is f in this line element, and accordingly I can apply this equation to this line element, and then I can compare the result with the equation, with this equation, and I identify the surface. So let us go. Now, I'm talking in general relativity in terms of 4 coordinate systems. These coordinate systems are x0, 1, 2, 3. So 0, this corresponds to CT, x1, it is r, x2, it is theta, x3, it is phi. These are the coordinate system in general. Now I can write the line element again. I'm writing here, but this time in terms of, instead of CT, I put x dot 0 square. This 0 identifies this 0 is the dimension. Okay, this is dimension. Now, this equation, in fact, is a function of the first dimension, which is this one, a function of the second dimension, which is r, a function of the third dimension, which is theta, and a function of the fourth dimension, which is phi. So, I will take first, for example, I will assume that f here, okay, this dimension. So if I look at the line element, the only term in which I have 0 dimension, or the first dimension is this term. Okay, so f here is equal to this one. For the second, for r, here, I have this quantity. This is a function of r. This is a function of r. So everything is a function of r. 1, 2. Can you find another function of r? Yes, this one. This is also a function of r. So in fact, for r here, f is equal to all this quantity, all this function of r. Now for theta, I have this term here and that term there. I have 2 terms. Now for phi, I have just this term here, minus r squared d phi squared. So in fact, I can determine what is f for each of the 4 coordinate systems. Let's start by the first one, this one. So f is equal to e to the nu. I have to put in mind that this nu is a function of r, and this is x dot 0 all squared. So I'm taking this element. This is the only element that contains the first dimension. Okay. So usually I do this ordinary derivation. I will not go through all this simple derivation, but I will get finally this equation. So this equation was obtained from here. Let's go once again. From here, I determine f, I apply this equation, and I get this equation here, up. Now I will compare this equation with this equation. Look, here r is what? Here r is the first dimension, r equal to 1. x0 is the 0 dimension, or whatever you call it, the t dimension. So this is 0. So if I compare this, look, this is 1 and this is 0. This is dimension 1 and this dimension 0. Of course, beta and eta are equal to 1 here. And what I'm left with this quantity in u dash is equal to gamma alpha beta mu. So I can now say that gamma alpha beta mu, alpha beta eta is equal to u dash. But what is alpha? Alpha here is the 0. Beta is 1. Eta is 1. So I have 0, 1, 0. Okay, 0, 1, 0. Because of symmetry, I have also gamma 0, 1, 0. So in fact, if I have this Christopher symbol, I should have this Christopher symbol because of symmetry. So instead of a new dash here, I have each of them is 1/2 a new dash. So this 1/2 comes from the fact that I have 2 terms which are identical, satisfying this equation. So in fact, by considering the first dimension, which is this one, I was able to identify 2 of the Christopher symbols. Now, I can do the same. I can do the same for for R. Now for R, I have, as I said, f is equal to this function of R, this function of R, that function of R. So I have all this quantity. Each term of this quantity is a function of R. So in this case, my f is equal to the whole thing. Now I can apply again the Lagrange Euler-Lagrange equation using this F, and I will obtain this equation here. This equation. Now, you can follow my notes and see how we can get it. It is easy. Now, look here. I have R double dot, which corresponds to the first term. Corresponds to this one. And I have many terms, 1, 2, 3, 4 terms. Now these 4 terms corresponds to each one, because I will compare it with this one. So let us go. For example, if I take this term here, lambda dash, R dot square. So R dot square I will write as R dot multiplied by R dot. Okay? So if I compare it here, it is R dot multiplied by R dot. And this is 1, this is 1, and R is 1. Which term? Yeah, this one. This corresponds to this. And the coefficient of R dot multiplied by R dot is this one, 1/2 lambda dash. I can do the same for this term. This is X dot multiplied by X dot. That means 0, 0. And I'm talking about R is equal to 1. So in fact, 1, 0, 0. This one here, there's a mistake, I think, because this is square. Huh? This, no, sorry. No, not square. This is R and this is theta dot. R is 1, as we said, and theta is 2. We said R1, theta 2, phi 3. Okay, x0, 0. So this is R1 and 1, 2, and I'm talking about R. So we have for this quantity, I have this. Where is it? This one. Yeah, I have 1, 0, 0. No, for this one. For this one, I have 1, 1.
Theta square.
2.
It should be theta dot
1,
square.
1. Sorry.
Theta dot square. There is a typos.
Theta dot square. Yeah, theta dot
It's
square.
2.
Theta square. It's 2.
Yeah, 2.
It's 2. Theta dot square. There's a mistake. Yeah, just theta dot square. This theta dot square, not R. Okay. So this is the way how I identify the Christopher symbols. I can do the same for F, for the theta, and I get this equation. Again, I compare this with the Lagrange equation, with the line element of Lagrange equation, and I will get these Christopher symbols, etc. And this is for the phi, also I can identify the Christopher symbols. So in fact, the 40 Christopher symbols are not all appearing in my equation. Using this technique, I am able to identify which Christopher symbols are not equal to 0. Now I have the Christopher symbols. What else?
I have to know lambda and u.
You have to know lambda and u. Yes, that's right. It is not easy. No, it is not difficult, but it's not evident. This is also I will just skip. If I have gamma, tau, see these are the same, and beta, this could be equivalent to this term here, log minus g, and this line here, that means derivative with respect to beta. Beta, that means x to the beta. Okay? in this case, beta could be 1, 2, 3, or 45. Here, skip. Okay, so the line element, which we have seen in the beginning, becomes this one. Log root of minus g, derivative with respect to mu, derivative with respect to mu, minus gamma, alpha, etc. Derivative with respect to alpha. Here I have product of two several symbols minus the several symbol multiplied by log root of minus g with tau. Now, next step, I want to solve this equation. This quantity equal to 0. This quantity equal to 0. So first step, I have to identify what is g mu mu. From the line element we just constructed, this is our method. This is our method. So in fact, this quantity here, g, is the determinant of the matrix. So determinant of the matrix g is equal to this term multiplied by this term multiplied by this term multiplied by this term. Okay. So let us do the exercise. I will have g equal to the product of these terms and taking the absolute value, and log minus g is equal to this quantity. I take the log because I need the log in the equation. I need the log in the equation. So I take the log and I will get this quantity. So now I have this equation that I have to solve, but now I know what is g and I know what is log g. Okay? So once these quantities are known, I can proceed to calculate the various components of this method. Now, the first component of this method, I will assume that mu equal to 0 and the nu equal to 0. So in fact, in this case, r 0, 0. Here log with respect to 0, and here I have alpha 0, 0, alpha. Here I have beta, tau 0. Here I have tau, beta 0, etc. So in fact, if I want to find R0, 0, I put the mu equal to 0, the nu equal to 0 in this term. And this is what I did here. Okay. So in fact, this log is independent of x0. So this term is automatically 0. I am left only with this term. I don't know why this. Okay. Right.
لأن من نحط شيء على الكمبيوتر, if you don't make it PDF, everything will mix up. So here I have a mix up because it's not a PDF file.
Okay, so in fact I have R00, etc. Now I have to identify these gammas. I will check what gamma I have with 0, 0 down. From the gammas I already identified, what gammas contain this term of this type, 0, 0, and then a number. Okay, so in fact I will find that this term here is 0, 0, 1. If I go to the list of several symbols I just identified, I will find that this one corresponds to 0, 0, 1. Now here I will have, look, I have beta, beta, tau, tau. So I look into my Christopher symbol that I just found, which contains such a configuration with this this letter here or this index here is the same as the index here, and index here is the same as index here. And I will discover that I have two configurations of this type in the gammas I determined. These are the configurations. Now this one, also I look into my gammas that I just find out which one contains 0, 0, and then a letter here. I will find the 0, 0, 1, etc. And I have log minus g with respect to 1, that means with respect to r. Okay, because r is equal to 1. And this quantity here, I replace the gammas that I found previously, and I end up with this differential equation. Please, this I cannot explain it more. What you can do, you have the sheet. In the sheet, you cannot just read it. You have to have a pen, a white paper, and check every step by step. Okay, this takes some time, but if you are acquainted with it, you find it easy. Now from this, I obtain this differential equation. With simple manipulation, I can find this is the final differential equation, nu double dash plus 1/2 nu dash square, etc. And I discover here that this equation contains two variables. One variable is nu, the other variable is lambda. And my friend said what we are looking for.
Another difference.
We are looking for nu and lambda. Okay? So this equation is not sufficient. I have two variables. I cannot find nu and lambda from this equation. What I do?
We look for the R11
Exactly. I look for R. Why not R12?
because it's easy. So
We will see why not R12. So let us look for R11. I do the same for R11, and I compare the Christopher symbols here with what I have obtained, and I will get this result here. All these Christopher symbols are the one we discovered. Again, if I substitute for the gammas, I will get this equation. This is an equation which is second order differential equation. It could be reduced to this one. This is also a differential equation which contains nu and lambda. Now I have two equations with two unknowns. Can I solve them? Yes. And the solution is very simple. I just subtract one equation from the other, and I will get this quantity here. Or if I integrate, I will get nu plus lambda equal to constant. In fact, in my solution, I am seeking a solution where at very big distances, R is very big, the E to the R and E to the lambda approaches 0. In that case, I have this constant equal to 0. If this constant equal to 0, see here I'm putting this requires that the function VR and lambda R tends to 0 as R approaches infinity. If constant equal to 0, I will get lambda equal to minus mu. Lambda is equal to minus mu. I solved the problem?
not yet.
No, not yet. I have to find lambda and the mu. So shall I do?
You actually substitute the dimension equation.
I substitute back in one of the equations, okay, and I will get an equation, second order differential equation, and lambda 1. And what I discovered, this equation could be written like this: r e to the minus lambda, second derivative is equal to 0. If I integrate this quantity here, I will get r e to the minus lambda dash equal to 0. So this is the derivative of this quantity, so equal to constant. Okay. So this is my solution for lambda. Now I can proceed. Next, calculate R22 by the same method, and I will end up with an equation of this type. Okay, and if I simplify it, I will get e to the minus lambda r dash equal to 1. Look at these. Previously, we find the same equation equal to constant. Now, the same equation equal to 1. What that means? Constant equal to 1. Okay, that means the constant equal to 1. Now this constant equal to 1, I can integrate this equation. If I integrate this equation, I will get this quantity here. E to the minus lambda r equal to r minus 2m. Now this is a constant of integration. Of course, somebody tell me why you are putting 2m. As we are going to see, this is very. I can put any constant I want. Okay, but I choose minus 2m for certain reason we are going to see. So in fact, from the three equations R0, 0, R11, R22 equal to 0, we have determined the value of E nu, which is e to the minus lambda, equal to 1 minus 2m over r. So this is E nu, and this is E lambda. The problem is solved. Now I can write, I know e to the lambda, I know e to the nu. So I can write down the line element, which is the complete solution in a free space. This is, so I substitute back E nu and E lambda in my original line element, and I will get this equation. This equation is very famous equation. Whenever you read solution of general relativity, you find this type of equation. But in this particular case, this is called Schwarzschild solution in a free space. Somebody will say, then what is it? And then you find this, yes. I have some phenomena happening in the universe. How can I apply this to something happening in the universe?
Maybe study this equation.
No, simply I can use this equation. But I have to extract information from this equation for a particular problem. This we are going to see tomorrow. Okay? So I have this equation. I can apply this equation for a particular case, ظاهرة معينة في الكون. I can apply it to that particular phenomenon. How I apply it? I have to extract something from it. Extract some information from it. How can I extract information from this equation? Can you tell me? كيف حصل على معلومات من هذه المعادلة؟ جواب بسيط. I use Lagrange Euler-Lagrange equation, and from Euler-Lagrange equation I can extract differential equations from these quantities and solve the differential equations for a particular case and find out. Okay? So in fact, this is just a shape of the solution. Application of this solution to a phenomena requires further work. I have to extract information, etc. But one important point here, what you observe in this equation. What do you observe in this equation?
When we put R equal to 2m, we have a similarity.
When put r equal to n, we are
We have a similarity.
singularity. صح. This is important. He said when you put r equal to m, we have a singularity. In fact, not only this, I have two singularities in this equation. Singularity here and singularity here. We can prove that this singularity, this is with change of coordinate system, this is not a real singularity. This is a real singularity. Now let us see this quantity we have just mentioned previously, which is the constant of integration minus 2m. What is it? I will go back to the classical limit g00, and the classical limit equal to 1 minus 2 gm over c square r. So in fact, this m is equal to gm over c square. Gm over c square, and 2m is equal to 2gm over c square. Now this quantity here is called Schwarzschild radius. أحد يعرف what is it?
The radius backlash.
Hmm?
Black hole. Black hole.
صح. طيب على what is the relation of black hole with our
The black hole is the
Singularity
essential
in the equation that is squared.
Look, I am talking about a free space. So my equation will extend, and where it will stop? At the event horizon.
Okay.
After the event horizon, I cannot talk about free space. I don't know what is there. Okay, so my solution extend up to the event horizon. Beyond the event horizon, I have maybe I have another type of energy momentum tensor, etc. So in fact, this is the Schwarzschild radius, which appear automatically in this equation. Okay, appears automatically in this equation. And I think that this is all what I can say today about the solution of Schwarzschild solution to the field equations in a free space. As I said, I passed very quickly through the algebra, okay, and I have some problem with the slide also. All this you can find it in the sheet. Will be available today for my lecture. You can have it on the WhatsApp, and you can go through the small details. And if you have any question about the algebra, you can ask me. Okay, so it is for you. Any question, please? Yes.
ده ممكن اعمل فري سبيس